All right, AP Chemistry, this is the answers video for the day 86 assignment, which is part 3 of the winter final exam assignment. So officially this assignment isn't assigned until January 20th. It says due January 21st. I'm actually going to make these winter assignments due on the Saturday, which would be January the 22nd, but that's a firm deadline because grades have to be turned in. If you do get it turned in by January the 3rd, though, you do get extra credit for it. And the answers videos, as you've been seeing, are not that extensive. I'm only going to go over a couple of problems. Really, all of these questions are answered in the lecture video. You need to watch the lecture video. Okay? Some of them are kind of long, but you will get all the answers in the lecture video. So that's effectively the answers video. Okay? So let's go ahead. So the first page is just asking you really to draw orbitals, and that's all in the answers video. So you should understand the shape of the orbitals and be able to answer, of course, the question, what is a hybrid orbital? Define that. All right, so that's what the first page is asking for. Second page is asking what is a sigma bond, what are pi bonds? Again, that's explained as clearly as I could possibly explain it. If I can't explain it, if it's not explained to you in the lecture video, come for tutoring, because I can't do it any more clearly than that, just writing on a piece of paper here. I realize that drawing in perspective and in 3D is difficult. Just do the best you can. What you should do definitely is kind of try to mimic what you see in the video and what you see, for example, down here, and label each of the orbitals very clearly so I can tell which is which and you can tell which is which. Okay, and then I did get some problems out of the book. These are not terribly difficult. I'll do this one with you so you get a sense of what they're asking for. So right here, zoom in for you here, and it says that all three balloons shown on the right are all the same size. What is the angle formed between the red one and the green one? So you can make up which is which. Let's just say this is the blue one. There's a blue one. There's a red and a green. You could just make that up. In your book, if you look in your book, they're in color, of course. Okay, so what's the angle? So if you have 3 equal angles, they're all going to be 120 degrees. So the answer to A is, you could just write that, 120 degrees for A, okay? B, if additional air is added to the balloon so that it gets larger, what happens to the angle between the red and the green balloon? What happens to that 120? So you're basically making this one bigger like that. So it's going to push down. It's going to push down, so it's going to okay, so it's going to push down on the red and the green, or the red and the green here. It's going to make that angle less than 120 degrees. That's what's going on there. I was a little off screen. Going to need to bring this out like that. So now you can go ahead and pause that and read that if you'd like. So more air in the blue balloon, that's the top one, will push down on the red and green and make the angle less than 120 degrees. Okay? For part C, what aspect of Vesper model is illustrated by part B? This would be, the blue balloon would be symbolic of or represent a lone pair of electrons. So okay, so if this became bigger, what that would be is, that would be a lone pair. Let's understand why that is. Let's say these are 3 equal atoms. Doesn't matter what they are, they're equal. So they have a nice even angle of 120 degrees between all of them. And remember what an atom has. It has electrons, which are bonding together here covalently, and it has protons up here in the nucleus, which it would be kind of in the middle of the balloons there. If you suddenly take the protons away from this blue balloon and make it only a lone pair, then you don't have a balance of positive and negative charges up above any longer. You now just have the negative charges of the lone pair. The positive has gone away. So if this is just a lone pair, it's only negative. And what's that going to do to the electrons in these 2 bonding atoms right here? It's going to push them down. It's going to repel them. So again, if these are all 3 are atoms, there's a balance, and they all have a nice equal angle of 120 degrees. If suddenly you take this atom and take away its nucleus so that only a lone pair are left, then that's a pure negative charge up top. It's going to push down on the negative charges here and here and make the bond angle less than 120 degrees. Okay? All right. Next. Now what I have put, let me show you this real quickly. Okay, so what I have put is the Vesper reference sheet in here. It's part of the assignment. You can always just pull out your own, though. So for some of these problems, you're going to want to reference that. So let's go ahead now and let's look at 9.6. So below are 3 pairs of hybrid orbitals, each with a set of characteristic set at a characteristic angle. For each pair, determine the type or types of hybridization that could lead to hybrid orbitals at the specified angles. Okay, so here we got 109.5, so maybe you have that one memorized by now. There it is. There it is. It's 109.5. That's a tetrahedral geometry, and that's SP3. You have a S and the PX, the PY, the PZ all joining into the hybrid, and that would form a 109 degree angle for that one. Okay? How about this one? This one's a little trickier. How about 90 degrees? Well, you got to go to this sheet and you got to go to the other side. And the place where you find 90 degree angles is down here in the octahedral. Those are all 90 degrees. All of those angles you see there are 90 degrees. So that would be SP3D2. That's extended octet. All right. So that's how you do that. So just go ahead and write out that answer. Okay, let's look at this one. And it says methane, CH4, and perchlorate are both described as tetrahedral. What does this indicate about the bond angles? So again, I want you to write a complete sentence, but let's just give you the answer. It means they're going to be about 109.5. Might be a little deviation from that, but that's pretty much, you can just say exactly if you want 109.5. That's tetrahedral. And of course you get that from, okay, and you get that from down here is 109.5 tetrahedral, and that's where you would get that from. That's the shape of that geometry. Okay, how about B? The NH3 molecule is trigonal pyramidal, while BF3 is trigonal planar. Which of these molecules is flat? Okay, so to do that, get out your periodic table. You should always have your periodic table out whenever you're doing anything in this class. We're gonna have to do the Lewis dot for this one. So let's do NH3. This is part B, by the way. So N, you have 1 times, and nitrogen has 5 valence electrons. That's the electrons in the second orbital. And H has 3 times 1. So that's 5. And that's 3, and that equals 8. So it has 8 total electrons. And for BF3, boron, one of those, and each boron has 3. And F, fluorine, there's 3 of those, and each one has 7. So that's going to be 3, that's going to be 21, that's going to be 24. Okay? All right, electrons. Get on screen here, 24 electrons. All right, so let's draw that. So the N is going to be in the middle. Then you got H, H, H. Okay, now we've got to place 8 electrons. So there's 2, 4, 6, and then the other 2 have to go there. They can't go around hydrogen. Hydrogen can only hold 2 electrons. So there it is. All right, how about the BF3? So we're going to do B. And we're going to draw it initially the same way we did for methane, ammonia. Okay, and we got 24 of those to place. So first we place single bonds, and then we place octets around the terminal atoms, the fluorine. Fluorine and hydrogen always have to be terminal atoms. Those are from your rules way back when we did this. Okay, so you have 8, 8, 8. That's 24. So everything is perfectly placed. Okay, so which one is flat? Well, the one that's flat is the one that doesn't have lone pairs. Remember what lone pairs do. They push down on these bond angles. They turn this into a pyramid. So this is trigonal pyramidal. This doesn't have any lone pairs in it. that means it's going to be flat. So this is going to be trigonal planar. Okay. All right, and that's all there is to that question. Okay, then you're asked to do a whole series of these right here. We'll do one of them together. There may not be enough space here to do this because what you're going to want to do is draw the Lewis dot structures. So let's draw HCN. So I'm going to do that without going through all the steps. I'll just draw it here. And let's see what we got here. HCN is going to be 1, 4, and 5. That equals 10. Okay, and there we have, everybody has an octet, and we have 10 electrons used. So what you have here is 2 electron domains. So you come over to this sheet over here, and we see that when you have 2 electron domains, it's going to be a linear molecule, and it's going to have sp bonding, sp. So what you're going to have here is an sp, and then you're also going to have an sp here for the carbon. What about the hydrogen? Hydrogen doesn't hybridize. It's just a single electron bonding with this sp. So you have sps. Whenever you have sp, you have to have 2 of them. Okay, you have to have as many as you have electron domains of the hybrid. So there it is. Okay, how about the nitrogen? Nitrogen, same thing. It has 2 electron domains, one on the outside and this triple bond. So nitrogen is also an sp. I'll draw it down on the bottom. And what's holding this lone pair is also an sp. All right, so this is going to be, for A, it's going to be linear, and it's going to be sp hybridization. And you might want to do this one on a separate piece of paper or somewhere where you have some extra space. Okay, that's how you would do that. You want to do one more? Let's do one more. Okay, let's do NH3C+, Cl+, okay? All right, so how do we do that? We'll come down here. So down here, and we're doing NH3 Cl+. Okay, so N, I'm just going to do it real quick. It's got 5 electrons. H, there's 3 of them, each has 1, so that's 3 electrons. And Cl, chlorine, if you go to your periodic table, you're going to see that it has 7 valence electrons. It's second from the end of the 3rd row. So it's got 7, but it's a plus. That means it's ionized. So that means the chlorine minus is going to be not 7, but 6 electrons. It lost an electron. Okay. All right, so what we have here is 14 electrons. Okay. Hydrogen can't be the terminal electron. We're going to put nitrogen in the middle here. So what we're going to do is N, H, 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 just like we did up in problem 912. And then we're going to put the Cl here. And we've got that, 8. And let's see what else we got. First of all, you want to put down the proper number, create an octet around the outside. So there you have 8, 10, 12, 14. Okay, we're good. There you go. There's your diagram. All right, so for the nitrogen, it's got 1, 2, 3, 4 bonding domains. And that makes it tetrahedral. So that's tetra. Okay. Now what about the Cl? Well, the Cl just has 1 bonding domain. So this is, by the way, is going to be sp3. I should write that. So the hybridization, we're talking about nitrogen again, is you just look at your sheet here. There's tetrahedral. There it is, sp3. All 4 of those are sp3 bonds. 1, 2, 3, 4, sp3. You have as many of the hybrids as you had electron domains. So 4 sp3. So hybridization is sp3. Okay, for chlorine, it only has 1 bonding domain. So it is basically not hybridizing. And so that's that, okay? That's all you need. You're really interested in the central atom anyway, okay? Anyway, that's how you do those. You do the other three. Again, line paper would probably be helpful. We come down here. What do we see? Trigonal planar, trigonal pyramidal, and a T-shape. So you can, whatever it's asking, okay, we'll just write that down here. Trig, planar. Again, I'm not giving you everything. Trig, pyramidal. And this one is T. Okay, and there you go. Whatever it's asking, you can figure that out. And that does it for this answers video. Again, I'm not going to give you all of them. Come to tutoring if you need help, okay? And I'll be happy to help you with any of the problems that you want. Okay, so that takes care of this answers video. Have a good day.